Okay, so here we are, section 9.1, like a glove, least squares regression. So, goals we got in this lesson: determine and interpret the least squares regression equation for a dataset using a formula, use interpolation to make predictions about data. That's what we're going to do right now with questions 1 through 5. Use extrapolation to make predictions about data. And then we got some key terms: interpolation, extrapolation, and least squares regression. So they want you to consider the following. How do the nerve cells in your brain communicate with each other? Signals have to be sent all the way across the brain, from your eyes to your occipital lobe. Little pronunciation struggle I had there. Maybe we should underline that and come back to that later. So we have a lobe in the back of our brain, and it's from our ears to our temporal lobe. And there's another one right there, and so on. How does this happen? In a sense, your nerve cells actually communicate using shapes. When a nerve cell is activated, it releases chemical messengers called neurotransmitters. These messengers have specific shapes, and they fit like keys into the locks on the next cell, receiving the message. This message tells the next cell what to do. And this process happens trillions of times per day. So they want you to just kind of keep that in the back of your head as we go through this lesson. Alright, music, anyone? So we got a table here, and it shows the percent of all recorded sales that came through the music store for the years 1998 through 2004. And they want you to represent this data as ordered pairs for the total sales that came through the music stores as a function of time. Now, they want you to use X to represent the number of years since 1998. So right here, I'm going to go ahead, function of time, but they want you to use X to represent the number of years. So what I'm going to do here is I'm going to say this function of time part, we'll say it's f of x, because they want the time to be x. And they want you to represent the data as ordered pairs. So when they say ordered pairs, meaning they want x, comma, y, with the percent of total sales that came from the music stores. Total sales that came from the music stores as a function of time. So there's our function of time right there. And right here, look, percent of total sales from the music stores. That's our f of x. So we can just put that right here, f of x. Now, we have to put something in to get something out. Remember, if it's a function, we use f of x, but we also have right here the y. If it's not a function, then we use y. But for ordered pairs, the y would be in the same place as the f of x. So you just got to be able to identify those. And what we'll do here is we'll look at 1998, because that's our time, our x. They want us to do number of years since 98, and they got x here. We're going to put our x above. The reason why we're going to do that is because 1998, this is the year we're starting at. So January 1st, 1998, that would be like the first day, and a year hasn't passed yet. You have to wait till January 1st, 1999 for 1 year to pass. So actually, if we're starting in January 1st, 1998, a year has not passed. That would be where we start from. That's why we put a 0. And then a year from then we've got 1 year that passes, and so on. So you notice each of the years, 98, 99, 2000, 2001, 2002, 2003, 2004. They just go one right after the next, so we can just go ahead and continue with the numbers in sequence. And then from there, now they just want the ordered pairs right here. So now we can get our ordered pairs. We've got our x and our f of x, or, where the y would be. So we go right here like this, 0, 0, comma, and then 50.8. So 50.8, that's the first one. Put a comma. For the next one, 1 and 44.5. 1, 44.5. And we'll put a comma. For the next one, 2 and then 42.4. 2, comma, 42.4. For For the next one, we got 3 and 39.7. So 3 and then 39.7. For the next one, we got 4 and 36.8. So 4, comma, and then 36.8. And then for 5, 33.2. 5, comma, 33.2. And then 6, we got 32.5. So we go 6, comma, 32.5. Okay, so now we've got our ordered pairs, and here they are. There's all of our ordered pairs. Now they want us for the next part, they say, use your calculator to construct a scatter plot of the data. Sketch the scatter plot on the coordinate plane. Label the axes. We could use a calculator, but we also could just take these points and then just kind of estimate where they go. Something they do want us to do is label the axes. So for labeling them, if you remember, our x-axis generally down here where the x-axis is, I've always had you guys remember it's time. Let me move that up a little bit. So we'll say right here, time, and then we could put in parentheses years since 1998. And notice up here our x, our input, these are all the years. And notice how these numbers, the 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 7, 8. That goes a little higher, but that's okay. And then over here, these numbers, notice it doesn't really start at 20. It's got this little zigzag motion. That means it goes from 0 and it skips all the other numbers, then jumps to 20. So it goes from 20 to 60. And all these numbers are between 20 and 60, so that works out nicely. So we just take, for our y-axis here, our label would be right here, percent of total sales from music stores. And we could go right here, f of x, we could put that down and label it percent of total sales from music stores. So that's our label for this side. And now we just take our points and we plot them. 0 and 50.8. So we go over here to 0 and we go up to 50 and it's 50.8. So we just go above it, probably about right there. 1 and 44.5. So we go right here to 1 and then 44.5, approximately about right there. The next one would be 2, 42.4. We got it right there, 2 and 42.4. So we'll go 2 and then 42.4, approximately right here. 3 and 39.7. 3 and 39.7. So here's 3. 39 would be about right here. 39.7. 4 and 36.8. 4 and 36.8. So right here's 4 and 36.8, approximately there. So we got 35 there. We go across. Now we're at 5. So 5, 33.2. 5, 33.2. So there's 5. 33 would probably be about right there, 33.2. 6, 32.5. Here's 6, and 32.5 would be approximately right there. Okay, so we've got all those sketched out. We've done everything they've asked there. Let's go to the next one. It says to describe any patterns you see in the data. Well, if we look at this, it's not quite curved, but it has really close to a linear pattern. So we could say the data has a linear pattern we could also describe what's going on. How do we know it's got a linear pattern? Well, we could say as time is going on, as time increases, we notice the data is decreasing. So this data here that's decreasing, that's the percent of total sales from the music store. So we could word it like this. As the number of years increases, the percent of total sales from music stores decreases. All right. So we did pretty good there describing that. So you should have two sentences here. Okay, let's move it up some more. It says use a graphing calculator to calculate the linear regression equation. So they want us to calculate the linear regression equation for the data. Round z values to the nearest hundredth. Okay, so to do this one, actually got to have you get a calculator. And here's what we're going to do, because they want you to use a calculator. So let me actually put this up. We'll go on, and let me go clear, because we want to start from a blank screen. Okay, so from here, here's what we're going to do. And let me move this over, because I want to write this down so you guys have these notes also. Okay, so we're going to go stat. Now I'll write that down. So we're going to go stat, and then we're going to go to edit. And then we'll push enter. Coincidentally, it's already at edit, so it's no big deal. Now, we've got L1 and L2. L1 would be our inputs, our x's, and L2 would be our outputs, our f of x, or our y. So let's go ahead and enter our L1s. So now I'm going to say enter x values for L sub 1, and I'm going to move this over. Enter y values for L sub 2, period. Okay, so I'm going to bring this back now. So here we go. I'm going to get my x values. Let me move the sheet down a little bit. So we start at 0. So I'm going to go 0. So right there it says L1. Enter. So we're still at L1, but now this is the second piece of data. So now I'll go 1, and I'll just go right down the list. 2, 3, 4, and then 5 and 6. And that's all we need, because we're only doing the ones that are right here. 0, 1, 2, 3, 4, 5, 6. And we got them right there. 1, 2, 3, 4, 5, 6. The 0 is up there. There it is. There's the 0. Now we got to go to L2. Now we got to enter these. And here we go. So I'm going to enter from right here. I'm going to go 50.8. Enter. 44.5. Enter. 42.4. Enter. 39.7. Enter. 36.8. Enter. 33.2. Enter. 32.5. Enter. Okay, so now we got all that data. Now that we've got all that, let's go ahead and go back over here. What we got to do now, so this is the first thing we're going to do. Now the second thing we're going to do, you're going to go back to Stat, and this time we're going to go to Calculate. So let's go to Stat, right here. Oh, let me move that up. Right here, Stat. It's a little bit of a glare. Now I'm going to go over. We got to go over to get to the Calculate button. See how it goes. We can go sideways. So we go to Calculate. So let me write down Calculate. And then from there, we want to go down to linear regression right here. Linear regression. And then it has the equation right there. A times X plus B. So I'm going to just write that step down to linear regression A times X plus B. And then, so we scroll down to it. Now I'll push enter. And let's write that down. Enter. And we'll push enter again. And it gives us the data. So you'll probably have to push enter twice. So now with this data it gives us, what we're looking at for our equation, y equals a times x plus b, well then we got to sub in our a and we got to sub in our b. So here's what we want to write down. Excuse me. Y equals a times x plus b. Our a was negative 2.967, and then it just keeps going on and on. We'll round it to the second decimal place. So we'll round this 6 up to a 7. So we'll get y equals negative 2.97. And then we have x plus, and then our b, we'll round to the second decimal place. So this 8 will bump up to a 9. So that becomes 48.89. Now we've got to make sense of all this. What does all this mean? Well, we could say X represents the number of years since 1998, and the Y, it's going to represent the percent of total sales from the music store. So this here should simulate this this visual representation of what's going on with all the sales, this equation here. So we could do that real quick, like we could say number of years since 1998 and then right here we could say percent of total sales. All right, so that looks good right there. Let's go ahead and finish up problem number 5. Let's wrap this section up, or at least this part of the video. It says, interpret the question of the line in terms of the problem situation. Okay. So if we were to look at it, we could say for every year since 1988, there's something that's been going on. Let me go ahead and move that around. So we got number of years since 1998 right here for x. And this one here would be the rate because it's multiplying by x. If we rounded that up, that would round to a -3. Since it's negative, it's decreasing. So we could say for every year since 1998, the percent of sales from the music stores has been decreasing because that's negative. And we could say it's decreasing at a rate of 2.97%, or we could round it up to 3 and say 3%. And we could also say that in 1988, the percent of sales from music stores in total, it was approximately right here, this 48.89%, because this would be our y-intercept. Or we could round it up to 49. We could say it was about 49. So let's go ahead and just write that down real quick.
Mitana, it's be at bedtime. It's 9. You're going to school tomorrow. What? Mitana, you need to go feed them. Okay, you need to go help. Sophia, you hear me? Because I'm busy. You guys need to sleep now. You're supposed to shower. You're sitting in the shower chair.
Okay. So I'm sure those of you, my students, could hear my wife in the background getting on my kids. All right, real quick, let's wrap this up. I want to leave you with this. If there's a linear association between the independent, the x, and the dependent, now your dependent represented by y or f of x, can be represented by either or, of the data set, or a data set, you can use a linear regression to make predictions within the data set. Using a linear regression to make predictions within a data set is called interpolation. So that's what we're doing. We're taking actual data, real data, of a situation, plotting it, looking at it, and trying to figure out how can we simulate this data with an equation so we can make decisions for a business, maybe to save money, maybe to maximize profits. So they're trying to see the future without knowing what's going to happen over here based on previous information. And so they call that interpolation. And that's what we've done. We've put together an equation using data that was provided. Okay. So we'll continue with problem number 6 in the next video.